Good morning and welcome to Geometry Section 7.5, Parts of Similar Triangles. Alright, in this lesson we will recognize and use proportional relationships of special parts of similar triangles, and we'll use the angle bisector theorem. So check out this big chart here. We're talking about special segments. These are things we already know about. We know altitudes, we know about angle bisectors, we know about medians, okay? An altitude goes from a vertex of a triangle and makes a right angle with the base. Okay, now if we have two similar triangles, the altitudes are proportional to the sides. So same idea, sides are proportional, their altitudes are proportional. Okay, angle bisectors, same thing. An angle bisector bisects the angle in the vertex of a triangle and connects to the opposite side. Those angle bisectors are going to be proportional, just like the sides. And finally, medians, same idea. We have a median. The median bisects the opposite side. That median is proportional to the side lengths. So we do the same exact thing. Just like how we're finding our missing sides of triangles, we can find these missing pieces, the altitudes, angle bisectors, or medians, by setting up proportions. Okay, so in our first part, if triangle ABC is similar to FGH, then we can set a proportion like this. With our altitudes, we'll start with something like our altitude AD over altitude of the small triangle, FJ. And we can use any two sides for a proportion. Now I started with triangle ABC, so I need a side from ABC, so it could be AC over corresponding side FH. Okay, same idea. All right, angle bisector, same thing. We can make a proportion with our angle bisector, so RT over LP equals, and again, pick any corresponding sides. So let's say we know RS, and RS corresponds with LM. Okay, and then our medians, same exact thing. Our median is CD, corresponding median is YZ equals, again, pick a corresponding side. So let's say that we know now in this case AB corresponds with WX. That's it. Okay, so we're going to use that to set up our proportions now. So here's our examples. So first thing, I want to make sure we're not getting these things confused. So let's identify what we have based on the given information. So in this first triangle, I can see that this segment here is 9, and I can see that it bisects this angle. So if it bisects this angle, those are the same. There it is. There's our angle bisectors. Okay, those are angles are congruent. So look at what we know. All we have to do then is take our angle bisectors, 9 over the angle bisector of the small triangle equals 12 over the corresponding side of the small triangle. That's it. Okay, super easy. If you got the hang of setting up these proportions with the corresponding sides, that's all there is to do. You cross multiply and solve. We get x equals 8. All right, next one. I see a segment going from a vertex making a right angle. That's an altitude. Notice we have altitudes in both triangles. Our altitude in the larger triangle is 3 over the altitude in the smaller triangle equals side in the larger triangle, side in the smaller triangle. Again, cross multiply and solve. We get x equals 9/4. Don't worry about the fraction. All right, now we see the segment going to this side, bisecting that side. That means it's a median. So same thing, let's take the median, 20 over the median in the small triangle equals 36 over the corresponding side, 18, and we cross multiply and solve, and we should get x equals 10. Okay, so there's 3 basic examples using each idea. Just make sure that you match up the corresponding parts correctly and you'll be good to go. All right, examples 4, 5, and 6. Okay, same exact thing. Now this is weird. Remember, the altitude does not have to be inside the triangle. In an obtuse triangle, the altitude will be outside. So x is that altitude. Even though it's outside the triangle, it's still a part in the triangle. So it's still going to have that same property. So take the altitude x over the altitude of the corresponding triangle, or similar triangle, equals side in the first triangle over the side in the second triangle. So we get x over 7 equals 10 over 8. Cross multiply and solve. And again, don't worry, we're going to get a fraction for our answer here. We'll simplify it. We'll write it as 35 over 4. Example 5. All right, now I see this coming down. I see that bisecting the base. I see those two congruent sides. That means it's a median. And look, we know the whole base is 15. We know the median here is 33. The median in the smaller triangle is x equals the whole side in the large triangle over the whole side in the small triangle. Okay, cross multiply and solve. We get x equals 22. And we get x equals 22. Sorry about that. All right, example 6. All right, here's an application problem. Not a big deal. Just take a second, read through it. In a catalog, a photo of a tent has a base of 6 inches and a height of 5 inches. All right, so not a big deal, right? This is the same idea. The photo is what the similar triangle is. So if we think about it, we have then really just a small triangle that looks like this of our tent. Okay, the base is 6 inches. The height, which the height makes it right angle, so the height is really our altitude, okay, is 5 inches. The base of the actual tent is 10 feet. Will I be able to stand in the tent without bending? And I'm 5'8", okay? So first of all, we know it's an altitude because the height makes a right angle. So we set up our proportion. Now, this is okay that this is in inches here and feet here. That's fine, okay? Because it's consistent with our ratios. So as we look at this now, we're going to set it up like this, okay? 5 over x equals 6 over 10. We're going to go ahead and cross multiply and solve. We end up getting x equals 8.3 repeating feet. Now, if you're 5'8" and the tent's 8.3 feet tall, of course, yes, you can stand because the tent is much taller than you. All right, now, the next theorem we have is the angle bisector theorem, okay? Now, this one's a little trickier because now we're using pieces again instead of whole sides. So you got to be careful when you're thinking about this, okay? So that angle bisector divides it into pieces. Let's read with me, fill in this blank here. An angle bisector in a triangle separates the opposite side into two segments that are proportional. Of course, everything's proportional in these similar triangles. Okay, so here's the way I like to set up my proportions. I like to use the side and the piece. Let me get a color here for you guys to see. So the side here and the piece. Okay, the side here and the piece. So when I set it up, that's how I like to do it. So RQ over that piece on its side equals, then we go to the side, other side, RS and the piece of that side. Okay, so that's the proportion that we're going to set up then. All right, so again, once you get this idea, this is really straightforward. So look at example 7. That's our angle bisector, 25 okay, so we have 25 over the piece, 20 equals x is the side over 28. So notice there's the side and the piece, the side and the piece, and then we set up our proportion just like that. Okay. Once we get that, it's not a big deal. That's what the relationship is. Cross multiply and solve, we get x equals 35. You have to recognize, though, it's an angle bisector. So if it's an angle bisector, I can use this relationship. Okay, only works if it's an angle bisector. All right. Now we're getting a little trickier. Okay, so here we have side and piece. 110 over 100 equals side. Try to get another color for you here. There's our side, there's our piece. Now we have to be careful here because this whole side, this whole side is 160. I just want this piece. So this piece is 160 minus 100, or 60. That's what we want to use. So our side is R, our piece is 60. Then we can go ahead and cross multiply and solve. We get R equals 66. All right. Next one, exact same thing. There's our angle bisector. I'm going to let you guys go ahead and take this one, set it up. We should get A equal to 5. Make sure you got this one. If you don't, check in with your teacher. All right, example 10, example 11. Again, angle bisectors, same exact thing. I'm going to set these up with you and let you guys solve them. Side x plus 7 over piece x equals side 17 over piece is 11. Go ahead, cross multiply and solve this. I got a decimal for this one, so make sure you double check me. And I got x equals 12.83 repeating. All right, and example 11 again. Now we're given this whole side. There's our angle bisector. We need this piece. That piece is going to be 46.8 minus that other piece n. So when we set it up, whole side over the piece. Use that whole expression. I'm going to put it in parentheses because I'm going to cross multiply. Equals whole side is 42 over the other piece, which is n. Make sure that setup makes sense. That's the tricky part. Cross multiplying, we've been doing a ton of. You guys are pros at that. Cross multiply and solve, we get 36n equals 42 times 46.8 minus n. And I'm going to let you guys finish this one up because my stylus is not liking this. And you should get n equals 25.2. All right, we're getting close. Just a couple left here, guys. All right, check out example 12. It looks like there's a lot here because of the way it's set up, but just mark your picture. That's what they're giving us. So we know these triangles are similar, so right away that tells us a lot. We know Km is an altitude, which means that's a right angle. That's a right angle. Also means that altitudes are proportional to sides. Good. All right, now we know KL is 28. There's a side. Nice. We know that KM, there's our altitude, is 18. So right away it looks like we're using an altitude and a side length. We know that PT is 15.75. There's our other altitude. So all we have to do here, set this one up, guys. Same thing we've been doing. Altitude and JKL over altitude and NPR. 15.75 equals side length in the first triangle over the side length in the second triangle, PR, which is what we want to know. There we go. There's our proportion. Cross multiply and solve. We get x equals 24.5. And example 13. All right, look at what we have here, guys. Two similar triangles. So we have angle, angle, right? And then we have a median. Okay, now that's great. The median's nice, it's there, but really all we have here are sides, corresponding sides of triangles. So we know the two triangles are similar by angle, angle, so look at the corresponding sides. 2x plus 1 over the corresponding side in the small triangle, x plus 4 equals 40. Corresponding side in the small triangle is 25. Okay, we match those up by the corresponding angles. Cross multiply and solve. Go ahead and pause it. This might take you a minute or two. Check your answer. X equals 13.5. All right, it's been a pleasure. Great work. Have a good one.